Hi everyone, this is going to be a video on kind of the difference between elements and compounds, how to identify them, and kind of some details about how we write them, how we abbreviate them, I guess would be a good word to use. So we know that pure substances can be broken down into either elements or compounds. So we have, let me pick a better color here. So we have pure substances. And pure substances can either be like these right here, elements, or they can be like these guys over here, compounds. So first, we need to make sure everybody knows that a pure substance is one type of particle. I don't want to say one type of atom. I don't want to say one type of molecule because those are exclusive. One type of particle includes all of the options that we have. An element is going to be a collection of one type of atoms. So collection of one type of atom. We can also say that if we're looking at the symbol, like you see right here, we're only going to see one capital letter. And we will see it on the periodic table. So it's on the periodic. So if we look at the periodic table, we see it up there, you know, aluminum, magnesium, sodium, it's an element. It's one of those things. On the other side, compounds, they're still pure because although they're made of more than one type of atom, here you can see we have circle elements and we have square elements. They're all bonded together to create one thing, one molecule, one compound. So a compound is two or more different atoms or elements or whatever word you want to use, bonded together to make one thing. So we have elements and we have compounds. Now, that's how we kind of tell the difference between the two. And I just want to point out the difference between how we write their symbols. So here we said there's going to be one capital letter in the symbol, always, all the time, no matter what. That means that in compounds, we are always, all the time, no matter what, going to see more than one capital letter. For example, right here, these guys are also compounds, and you can see there's a capital R and there's a capital S. Now, there is a little Q over here. So what is the relevance? What is the importance of this uppercase, lowercase thing? I'm just going to go up here. So when we have an element symbol, the first letter is always capitalized. So the first symbol, I'm just going to put these notes over here. The first letter is always capital. And that might be it. Then maybe there is only one letter. And if there is, it is always capital. If there's a second letter, so if a second letter, it's always lowercase. And that's important. It's required. And the reason is, this is the example I gave in class. If we have PB versus PB, looks like the same thing, except one of them, the B is lowercase, one of them, the B is uppercase. This right here is the element lead. Whereas this right here is a compound made of two elements specifically phosphorus and boron. And the way that they behave, the way that they react, it can literally be like a life or death thing. Lead, if you get it in you, you could die. Whereas, I don't know, phosphorus monoboride, I have no idea if that's even a real thing, but maybe it doesn't kill you. And so it's relevant. It's important when, writing these symbols that you're paying attention to capitalization. And then the last thing that I just want to talk about has to do with compounds. You'll notice that here we have two formulas for compounds, SQR3 and then TSQ. The biggest difference here when I look at these is this little 3. This has a subscript, whereas the other one doesn't. And if we look at the atom itself, the particle itself, TSQ has one triangle and one square bonded together, whereas SQR3 has one square, but then it has 1, 2, 3 circles. So that must be that R. So I'm just going to rewrite this over here. SQR3, this 3 right here, subscript, tells us how many of that atom tells us how many of that atom there is, but not just how many there are or there is, but how many specifically in one molecule, in one compound. So the subscript tells us how many of that atom, what the heck, I can't spell, how many of that atom there, how many, I don't know if it's R or is, I don't know why I'm struggling right now, how many of that atom, let's just word it like this, are in one molecule. So it's not like I just have, 3 circles hanging around. No, that's not what that means. It means that the circles are touching. 1, 2, 3. And then there's also, the square there too. So subscript tells you how many of that atom are in one molecule. And then I did bring up in class that we can have coefficients. So let's say I had a 2 right here. That would tell me, so that's a coefficient. I don't know if I spelled that right, but it tells me number of actual molecules present. So if I look over here, I see 1 SQR3, 2 SQR3. So I have 2 particles, 2 molecules, each of which has 1 square and 3 circles. So that is elements and compounds in a nutshell. Definitely feel free to check out the classification tree. It's in your notebook, and it definitely has some more detail about elements and compounds, as well as some examples for you. Yay!